All right, so when we are programming, it's a good idea to have, especially when we're doing the types of programs that we're doing right now, it's a good idea to have some idea of how you're going to test your program to see that it works. Okay, so far we've been doing, a lot of programs where it's like enter your name and then it says hello to whatever the name you entered. So you look at it and you're like, yeah, that works. Okay, these problems that we're working on are a little more mathematical, may not be quite clear how you're testing. Okay, so testing your program. Okay, what we talked about yesterday was that each of these programs follows this kind of paradigm where we're inputting some values, we're processing those values, and then we're outputting a new value. Okay? And so what we want to know is that if we have good input, do we get the expected output? And so for the problems that we're looking at right now, we got to figure out what that expected output is. All right, so let's look at a couple problems here. Here's the similar triangles problem here. And this is that classic problem of, and I'm sure that you've done this in a math class before, okay? So this is that classic problem of like, we're standing next to a tree, right? So here we are standing next to this tree. We know how tall we are, right? But we don't know how tall the tree is. But we do know that there's the sun, okay? And it's casting a shadow, right? And we can measure how long that shadow is. Good job of drawing there, okay? And we know how tall we are, and we can figure out, right, how long our shadow is. And so we can use these similar triangles to figure out how tall the tree is. Why do we want to know how tall the tree is? Because we stuck our frisbee up there and we got to get it back and we got to figure out how big of a ladder we need. Okay, so we're going to figure this thing out, right? So we're going to say like, okay, well, I know that I am 6 feet tall. Okay, I wish. And the shadow length, right now for me is 8 feet long. Okay, and I know that this tree has a shadow length of, let's say, 24 feet long. Can I set up a proportion to figure out the height of the tree? Okay, so I'm sure that you've done this before in a math class, but we go, okay, well, my height to my shadow length should equal the tree height to the tree shadow length. All right, and then if you multiply by 24 on both sides, those 24s cancel out. 24 divided by 8 is 3. 3 times 6 is 18. So we figure out that the height of the tree should be 18 feet. So why are we doing this? Well, I'm just trying to give you guys kind of data that you can use for that problem. Okay? So when you're doing this problem, you're going to be asking for, right? You're going to write a short program that prompts the user for both the shadow lengths and the known height. Well, the shadow length of the tree was 24 feet. The shadow length of me was 8 feet. The known height was me, that's 6 feet. And I'm telling you now that you should get back, when you put those things in, you should get 18 feet back for the height of the tree. Okay? So we're saying in our program, we're going to input, okay, going back up to here, we're going to input 6, 8, and 24, okay? This is height, shadow 1, height 1, shadow 1. This is shadow 2. And I should get height 2 back to be 18. Is this making sense? All right. So that's one of those problems. And what we want to do is we want to figure that stuff out before we run the program so that when we do run the program, we can check and see that what we did was right. Okay? Let's look at another problem. Area of a triangle. Okay? I would venture to guess that if you go to your current math teacher right now and say, hey, does this formula for the area of a triangle work? They probably would look at it and say, I'm not sure. Okay, it's not a normal area problem. Okay, when you guys think about area of a triangle, what formula do you think of? What's the area of a triangle formula? Please tell me you know. Please tell me you know. What? Yeah, base times height divided by 2, right? 1/2 base times height. Okay? You guys know where that comes from? It comes from, yeah, like cutting a rectangle in half or a rhombus in half, okay? All right? So, little math mini lesson here. Say that I take any triangle I want, okay? And I want to know the area of that triangle, okay? So one way that I can figure this out is if I duplicate that triangle, okay? And I made myself a goofy looking triangle here, but if I duplicate that triangle and flip it over, then maybe it looks like that, okay? And that looks like it's at least a parallelogram, okay? The area of a parallelogram is base times height, but I only want half of that because I only want the triangle half. So that's why we're taking that times 1/2. Okay? So I don't know if that helps you at all. But let's take a triangle that I know the height and base of. So if I take a triangle like this, 3, 4, 5 triangle, that's a Pythagorean triangle, okay, or Pythagorean triple, okay. The base is 4, the height is 3, and if I use this formula, then area equals 1/2 times 4 times 3. 1/2 of 4 is 2 times 3. My area should be 6 for that, okay. So for this problem, area of a triangle, you're writing a program that calculates and displays the area of a triangle. The program will accept the lengths of the 3 sides as input from the user. Okay? So you're going to ask them for side A, side B, and side C. Okay? And then do this math to figure out what the area is. What I'm showing you here is if you give them 3, 4, and 5 for A, B, and C, that you should get an area back equal to 6. If you don't get an area equal back that's equal to 6, then you know that something's wrong with your program. Okay? So the whole idea here is have values that you know are good input and check to see that you get the expected output. Okay? Let's look at a couple more problems here. Okay? So area of a regular octagon, take a side, square it, multiply that by 2, multiply that by 1 plus radical 2. You guys can do that on a calculator and check that, okay? So hopefully you can do that on your own. Let's look at the quadratic formula, okay? Quadratic formula is a weird one because it's describing the roots of a parabola, okay? So let's talk about a parabola first. Okay, what does a parabola look like? It looks like a U. Okay, good. So we're used to thinking about a parabola that looks like this, right? Something like that. This is called a root. This is also called a root. If I know the equation of this parabola right here, I can use the quadratic formula to find those two values. Opposite of b plus all this stuff, the square root of the, I just lost the name of that in my head here, square root of the determinant, and then divide that by 2a. Second root is going to be the opposite of b minus square root of the discriminant is what it is, not the determinant, discriminant, all divided by 2a. Okay, so anyway, when you run your program, if you do this, you might get output that says the roots are NaN and NaN. Okay? What does that stand for? Not a number and not a number. So how can we get roots that are not numbers? Well, if you put in stuff that gives you a parabola that looks like this, that parabola does not cross the x-axis, so it doesn't have what are called real roots. Okay? So this guy has no real roots. So we want to make sure that we put in values that give us roots. Okay? So in other words, there's what we call imaginary roots, but we're not in an Algebra 2 class, so we're not going to be talking about that. Okay? So let's make sure that we have some real roots. So let's say that y equals, and let's just come up with some things that give us roots. So 3x minus 6 would give us a root of 2. Does that make sense for everybody? X plus 5 would give us a root of negative 5. Okay? So now I know what my expected output is. I know my expected output is 2 and negative 5, but now I got to figure out what the coefficients A, B, and C are, and I would do that by factoring out this, or not factoring, but distributing this out. So 3x times 6 is, or times x is 3x squared. 3x times 5 is plus 15x. Negative 6 times x is negative 6x. Negative 6 times 5 is negative 30. And if I combine like terms, 3x squared plus 9x minus 30 is my equation for y. You guys all understanding that? This tells me that when I use this program, I want to enter in A equals 3, B equals 9, and C equals negative 30. All right? And it should tell me that my roots are 2 and negative 5. You guys following that? Okay, so I'm trying to give you numbers that you can plug in to check your work. All right? And again, the whole idea is when I get input and process it, am I getting good output? Okay? Input 3, 9, negative 30. If I wrote my equation correctly in Java, I should get the output 2 and negative 5.